Okay, this is one of the coolest things that we will consider here. Coming attractions, a cow walks onto a beach. Yes, so we have already learned that the cattle livestock actually contribute significant amounts to methane emissions, and beef production is one of the most environmentally intensive in terms of land use, grain consumption, and so on. I don't know, I forgot something else. This is the story that came empirically out of the experience of this dairy farmer called Joe Dorgan. On a modern-day Prince Edward Island, Canadian dairy farmer Joe Dorgan observed that cows in his seaside paddock were healthier and produced more milk than those pastured further inland. He began gathering seaweed tossed ashore by storms and feeding it to all his animals. It did not take long for Dorgan to recognize he had a business opportunity on his hands if he could get his seaweed feed approved for sale. So it turned out that the science behind the seaweed, especially Asparagopsis taxiformis, is pretty solid, and its chemistry is now pretty well known. And some of the numbers produced in the lab are pretty amazing in terms of its ability to reduce methane production in livestock like cattle and also goats and sheep. Global anthropogenic greenhouse gas emissions by gas in 2015 from Let's Talk Science shows almost all of it is, well, 3/4 of it is carbon dioxide, and methane is 16%. Nitrous oxide and other gases make up the rest. And we know that we have to worry about not just the amount, but the greenhouse warming potential and the residence times and so on. Methane has almost 25-26 times the greenhouse warming potential of carbon dioxide with over 100 years, with a residence time of about 12 years. So anything we can do to reduce methane emissions is obviously good. In terms of the sources of methane, 30% are from natural sources like wetlands, for example, and permafrost, which is increasing because of the warming. 40% of methane is from agriculture, and 30% is from other sources. Actually, it turns out about 30% is what is attributed to emissions from livestock or ruminants in general as well. So cow and other ruminants have this kind of incredibly inefficient digestive system, thermodynamically speaking, where they have basically a sense of smell and some additional sensing organ in their mouth. I think it's called Jacob's organ or something like that. You can often see cows looking up, flaring their nostrils, opening their mouth and smelling. So they eat all kinds of junk in India, especially plastics, cardboard and so on. And they just put it into one chamber, and then when they are sitting around, they bring it back up and they chew it, and that's called enteric fermentation, where the process of using all the cellulose and all the other material they have consumed to convert to carbohydrates ends up producing enormous amounts of methane by the microbes that are helping with the digestion, and that ends up putting out methane from both ends, or I think majority of it basically comes from the belches. So that's the enteric fermentation process, and this is from Clean Air Coalition, which also puts out incredibly good amount of data on emissions, just like Our World in Data. So enteric methane emissions, it's showing comparative warming effect in 100 years, so that's 26 times. Ruminants' global methane emissions is 30% of the total. Global distribution of enteric methane emissions from ruminants in percentages: cattle is 77%, buffaloes are at 14%, and small ruminants like goats and sheep are at 9%. And the good news about this red algae, its biologic name is Asparagopsis taxiformis. I looked for maps. It seems to grow pretty much everywhere in the tropics to mid latitudes and temperate latitudes. And the basic chemistry has been understood now. It has something called bromoform, which seems to interact with the algae, the methane forming processes with vitamin B12. And in artificial rumens that were created in the lab, that are used in the lab to see the impact of rumination, impact of Aspergillus taxiformis on methane production, is that it can reduce methane production by almost 90% or more, with just 2% of the feed being this particular algae. And similarly high numbers were found in sheep and goats as well. But this is in the lab. Actual field experiments or actual experiments on cows to measure the reduction in methane haven't been done yet. But when the waste production into methane is reduced, that is converted into biomass, which is what gives cows more weight in terms of meat and more milk production. That was the mechanism that Dorgan observed empirically by looking at cows that were eating seaweed on the beach. So the idea is then to grow seaweed, Aspergillus taxiformis, to feed to the cows, and the numbers are not great in terms of how much space would be needed to grow, even as aquaculture, this particular algae. But we have talked about marine permaculture and the benefits of marine permaculture for increasing oxygen uptake of carbon dioxide, habitat suitabilities of growing food chains, and so on and so forth. So those can be combined with this algae aquaculture, and also managed grazing and reduced meat consumption and so on, to basically make this a very viable solution. Again, keeping in mind that the best strategy is to just simply avoid meat consumption, but that's not going to happen anytime soon in terms of behavioral change. So we are basically aiming to see what other ways there are of accomplishing multiple things, like reducing methane emissions from cattle and increasing their meat quantities, increasing their milk production, and combining with other ways with marine permaculture to also improve fish yields, carbon uptake, and so on, and as a whole make it a good coming attraction